Hello everyone, welcome back to Math Online. I'm Mr. Solis, and on today's video, we will talk about using the inverse tangent ratio. Today's objective is students will be able to use the inverse tangent ratio to solve for missing angles of a right triangle. If you are ready, let's move on to the next slide. Before we start, we want to recall some information. The tangent ratio is used to find the missing sides of a right triangle, and that's what we've been doing for the past few weeks. On today's video, we will learn that the inverse tangent ratio is used to find the angles of a right triangle. So the ultimate goal is to find the measurements of angles on a right triangle. Okay, so here we go. Inverse tangent states the following. If tangent of A is equal to x, then the measure of angle A is equal to inverse tangent of x. So in other words, what this is saying is the following. The measure of angle A, or any angle, will be equal to the inverse tangent of any ratio, any fraction, any decimal, any number that you have here. Okay, so remember this minus little one, the negative one, just means inverse tangent. Okay, so here we go. Let's look at some examples to better understand this. All right, so first scenario, find each angle measure to the nearest degree. So the problem says the following. Tangent of angle W, or tangent of W, is equal to 0.2126. Now, there's two things that we need to understand. First of all, this is the angle that we are trying to find. We want to know what the measurement of this angle is, angle W. We know that the ratio is 0.2126. This is your ratio, this is the missing angle, okay? So in order to find the measurement of angle W, what we want to do is take the inverse tangent on both sides of the equation, the left side and the right side. So here we go, let's do this. So we're going to say the following. Inverse tangent, don't forget your negative one, to say inverse tangent of tangents, or actually, let me use a different color here. Let me use blue. So inverse tangent of tangents of W, okay, is equal to the inverse tangent of this ratio, right? So we'll say the following. We'll say the inverse tangent of the ratio that we were given, and the ratio is 0.2126. Okay, so there it is. That's all I did to both sides of the equation. I took the inverse tangent on both sides. Here it is, inverse tangent, inverse tangent. Now, when we simplify this equation, on the left-hand side, inverse tangent and tangent, they will simplify each other out. So in other words, it will cancel out. So we're going to say inverse tangents and tangents simplify each other out because they're inverses of each other. So therefore, we're left with W. So we're going to write W is equal to inverse tangent of the ratio 0.2126. Okay, so there it is. Sorry about the handwriting, guys. Remember, I am using the mouse to write all these numbers and letters. Okay, so here we go. So next step, in order to know the measurement of angle W, we need to calculate this number in a calculator. So what we're going to do is go to our browser, and remember, you need to go to Desmos.com. I'm already in Desmos.com, and what you want to do is go on the left-hand side, and where it says scientific, you'll click on scientific. Remember, I told you guys that this is a better calculator for you guys to use. So click on it, and calculator will open like this one. And the first thing is to double check that your calculator is on degree mode. As you guys can see, This is on degree mode already. I'm ready to start the problem. So we know that we want to use the function inverse tangent, not just tangent, but inverse tangent. So therefore, you have to go to this menus on the top. Notice that there's the menu with the point main, ABC, and funds for function. So you want to press function, the menu function, and then you're going to see all these functions. So what you want to do is click on inverse tangent, the one with the little -1, right? That represents inverse tangent. So click on inverse tangent, and the next step is to type in your ratio that you were given. Okay, so here we go. The ratio that was given to us was 0.2126. So therefore, where's my numbers at? I don't see the numbers, so guess what? You have to look at your menu. Instead of functions, we're going to go to the main menu, click on it, and now you see your numbers. So you're going to type in 0.2126 because that was a ratio. Okay, so now it'll give us our measurements in degrees, our answer. So I'm going to copy and paste this, copy, go back to my slides, and I'm going to paste it. So I'm going to say W is equal to how many degrees? Well, here's the measurement. Let's see if I can paste this. Paste. So we know that the tenth decimal place is actually 0, right? So that's all we need to be, so that's actually all we need, the first decimal place, which is the 10th place. No big deal if you're not able to copy and paste the other numbers, or, well, actually you guys will be able to because you guys will have a calculator. You'll be able to see the rest of the numbers, but all we need is the first decimal place, which is the 10th place. So here's the thing. I'm going to look at the 10th place and say, ask myself, is this number 5 or bigger? So all 209 of you guys should say no. So therefore, since this number is not 5 or bigger, our degrees will remain the same. Remember that if the 0 was 5 or bigger, then our 12 will increase 1 more units. So instead of 12, it would be 13. But in this case, it's not the case, so therefore we'll leave it at 12. So we'll say that W, or the measurement of angle W, is equal to 12 degrees. And that is our answer. So just remember, what does this mean? It means the measure of angle W is equal to 12 degrees. And that's what we were trying to find. Find each angle measure. And the measure of angle W is 12 degrees. All right, so if you guys are ready, let's move on to the next slide. Okay, so before we start example 3, I would encourage you guys to try this example out. And if you get the answer correct, that's awesome. If you don't, no big deal. You can always watch the video again. So here we go for the rest of you guys. So we're still finding the angle measurements, and we're still rounding to the nearest degree. So our problem says tangent of U is equal to this specific ratio. So the first step is to identify the ratio, right? So we find the ratio. This is the ratio that was given to us. Now we will find the angle that we are looking for. So this is the angle that we are looking for. We want to know the measurement of that angle, okay? So here we go, guys. In order to do that, we need to take the inverse tangent on both sides of this equation. So we're going to say the following. Inverse tangent on both sides. Inverse tangent, whoops. Let's go ahead and delete that first piece because it doesn't look like a negative. Sorry about that, guys. So here we go. So tangent inverse of tangent of U, in parentheses, right, is equal to inverse tangent of what ratio? Here it is, 0.1405. There it is. Okay, so now that we have our equation all set up, we're going to start simplifying. So on the left hand side, we can see that the inverse tangent and the tangent will simplify each other out. Once again, why does this happen? Because they are inverses of each other. Okay, so therefore they will cancel out, and we're going to be left with U equal to inverse tangent. So we're going to say inverse tangent of what ratio? Well, 0.1404. Whoops, 05. All right, there it is. Okay, so now we want to calculate this number, so therefore we need to go back to our calculator. So we're going to clear the screen first of all. Clear the screen. We want to look for the function. So function of inverse tangent, and we will now go back to our number. So we have to go to the main menu and type in our ratio, which is 0.1405. Okay, and that'll give us the measurement of the angle, which is given to us right here. Let's see if I can copy everything. If I can't, remember that the decimal value after the decimal point is 9, or in other words, the tens place is 9. So just keep that in mind. So 7.9, in case the copy and paste doesn't work. It hasn't been working. I don't know why. So let's see if it does. Oh, first two numbers, which is what we need. So here we go. So we're going to say that U is equal to, oops, that looks like a V. Let's do that again. Remember, guys, I'm using the mouse, so it's really hard to write neat on the smartboard. So U is equal to 7.9, and remember, all you need is the tens place, so that'll be fine even if we couldn't copy the rest of the numbers. Okay, so now we look at the tens place and we ask ourselves, is this number 5 or bigger? In this case, yes it is. So therefore the 7 will increase one more value, one more units. So we'll say that the measurement of angle U is equal to 8 degrees. Whoa, that's a horrible 8, guys. Let me erase that. All right, so that's equal to 8 degrees. That's a lot better. Not perfect, but a lot better. So the measure of angle U is equal to 8 degrees. Now that you know how to find the measure of any angle using a calculator, let's move on to the triangles. Okay, here we go. All right, so now we see example number 4 with a triangle. So this problem is asking us, find the measure of the indicated angle to the nearest degree. So we are still trying to find out what the measurement of the angle is, and we're still rounding to the nearest degree. So that has not changed. The only difference is that now we have a picture, we have a diagram, we have a triangle, right? So now here's the thing. As you guys can see here, we have two sides given. We have this side with the 43 units, and we have this side with 40 units. And we also have the little box which represents the 90-degree angle, and we were also given the angle of interest. Okay, the angle of interest will be labeled with this line and the question mark for these problems. Now here's the thing. In most textbooks or in most assignments, you will not see a question mark as your angle of interest. Okay, so just keep that in mind. In most problems, or maybe in another math class, what you will end up seeing as your angle of interest is some Greek letter. Okay, so the most common Greek letters that you will see as angles of interest are the following.
So as you see on the screen, these are the 6 most common Greek letters that we use in mathematics. The first one on the left hand side, alpha, the one in the middle, beta, the one on the right side, gamma, the one on the left bottom side, theta, the one in the middle, phi, and the one on the right bottom side, delta. So these are the ones that you might see on textbooks in future math classes. With that said, let's move on.
So let's get started. Before we start this problem, let's remember a phrase that we learned in the past. If you guys remember this phrase, SOHCAHTOA, the first letter tells you the function, sine, cosine, tangent. The last 2 letters tell you the ratio. So in this case, we would need opposite over hypotenuse. On this case, we would need adjacent over hypotenuse. And the last scenario, we will need opposite over adjacent. Okay, hopefully you guys remember that. If you don't, please watch the previous videos that we have on our channel. All right, so in this lesson, I will tell you now, we will only be using the tangent function. Okay, that's all we're going to be using on today's lesson. So here we go. First of all, like we did on the past, we need to identify all 3 sides. What is what, in other words, okay? So across the 90-degree angle, we agree that we will always find the hypotenuse. Okay? So across the 90-degree angles, you will always find the hypotenuse. Next, this is the angle of interest. And the angle of interest is really helpful because across from the angle of interest, you will always find What side? The opposite side. Hopefully you guys remember that. I'm going to label it with the no for opposite. Okay. Now, if you know the opposite side, you know the hypotenuse, by default, you should know that the missing side should be the adjacent side. Okay. So you got opposite, hypotenuse, and adjacent. Now, there are 3 sides on a triangle, and only 2 of these sides have numbers. So that means that you will only be using the opposite side and the adjacent side. And which function satisfies these 2 sides? Oh, tangent. O and A for tangent, right? Opposite over adjacent. So just keep that in mind. So first of all, I want to write my equation. So I'm going to say tangent of what angle? I do not know what the angle is. So instead of using a question mark for my angle, I'm going to start practicing with the Greek letters that I just mentioned earlier. Okay. So I'm going to use data. So data goes a little bit like this. Okay. So let's use data. So tangent of data, which is the angle of interest, is equal to what ratio, guys? Opposite over adjacent. So that would be 43 over 40. Awesome. So here's our equation. Okay. We're going to take the inverse tangent. So inverse tangent of tangent of data, right? You could put your little parentheses here if you want, equal to inverse tangent, once again, inverse tangent of the ratio that you were given. So 43 over 40. So as you guys can see, all I did was apply the inverse tangent on both sides, okay? Because if you see, this part was already on the equation, and the ratio was already in the equation, okay? So I just took the inverse tangent on both sides. Now, as I said before, when we simplify the left side, the inverse tangent and the tangent will simplify each other out. Why? Because they are inverses of each other, okay? So they will cancel out, and we will be left with data. So here we go. So data is equal to inverse tangents of what ratio? 43 over 40. So as you can see, these problems will be done exactly like the ones we did earlier. So now, if I want to know the measurements of the angle data, I need to calculate this number on the calculator. Okay, so I'm going to go back to my calculator, and I'm going to clear the screen, and I'm going to type in, first of all, the function itself. So inverse tangent of what ratio? Go back to the main menu and type in your ratio, which in this case was 43 over 40. And that'll give you the measurement of the angle. Okay, so I'm going to copy and paste. Hopefully I can copy and paste the entire numbers. So copy, and I'll take it here. Let me write data again. So data is equal to oh, it actually copied all the numbers. Yay, that's awesome. It's working again. I'm not sure what I did different this time, but it's awesome that it's working. It's pretty epic. So we want to round to the nearest degree. So the nearest degree is literally the first value after the decimal points, which is the tens place, right? So I'm going to look at the tens place, and I'm going to ask myself, is this number 5 or bigger? No, it's not. Therefore, the 47 will remain the same. If it was, then the 47 would increase 1 unit, right? But since it's not the case, I'm going to leave data is equal to 47 degrees. And that's my answer. So the measure of angle data, or the measure of the angle of interest, is equal to 47 degrees. Awesome. All right. Hopefully this was helpful. Like I said, the question mark became the data, the Greek letter data, okay? So that's what I'm using. If you want, you could write the question mark instead of the data. That's up to you. No big deal. It wouldn't be wrong to do that. But I like to use data which is totally fine, right? You can use the question mark or data. Either one will work. All right, so with that said, let's move on to the next scenario. So example number 5. On example number 5, they're asking us to do the exact same thing. They want us to find the measure of the indicated angle to the nearest degree. And you guys should know that the indicated angle is the angle of interest, okay? So that's the little question mark. And just like on the previous example, as you guys saw, I actually changed the question mark to data, okay? So if you guys want, you can cross out the question mark and write data if you want, okay? So first of all, remember, you would have to find out what function you're going to use, sine, cosine, or tangent. But like I said, in this case, we're just going to be using tangent, and we're going to find out if it's true or not, okay? So across the 90-degree angle, we will always find the hypotenuse, okay? Now, across the angle of interest, data is the angle of interest. So across the angle of interest, you will always find the opposite side, okay? So therefore, the 37 has to be the adjacent side. Awesome. All right, so with that in mind, we will write our equation. So this would say tangent. Do we know what the angle of interest is? No, we don't. So I'm just going to write data. So here we go. So tangent of data is equal to, what's our ratio? Opposite over adjacent, right? For tangent. So opposite over adjacent. So 62 over 37. Okay? Remember, so katoa. Okay? So here we go. So now, this is our equation. Normally in the past, we created a proportion and then used the cross product rule to find out what the missing side was. But we're not looking for a missing side. We're actually looking for a missing angle. Okay? So we want to know what the measurement of data is. Okay? Or the question mark, whatever you want to call it. So here it is. In order to do that, we need to take the inverse tangent on both sides of the equation. So I'm going to take the inverse tangent on both sides. Inverse tangent of tangent of data. There it is. And I will close my parentheses. Boom. So that parentheses goes with this parentheses. Equal to, remember what you do to one side, you have to do it to the other side. So therefore, I'm going to say inverse tangent again. Inverse tangent. Don't forget your little negative one up here. Of what ratio? 62. Whoops. 62 over 37. So when we simplify this equation further, on the left side, we know that the inverse tangent and the tangent will simplify each other out. Why? Because they are inverses of each other. Okay, so therefore they're going to cancel out. So we cancel these out and we're left with the data, the angle of interest. So here we go. Data is equal to inverse tangent of what ratio? 62 over 37. Awesome. Okay, so here we go. So in this case, we're ready to use the calculator. So we're going to go back to our calculator. Just remember your ratio, 62 over 37. So we're going to click on here. We're going to clear the screen. And once again, you'll go to functions. And you will look for the button inverse tangent. And then you'll type in your ratio. So in this case, I believe we have to go back to our main menu to get the numbers. So I believe we said 62 over 37, if I'm not mistaken. 37, okay. So that will be our measurement of our angle of interest, which is theta in this case. So let me copy and paste this. Copy and paste. Hopefully the copy and paste is still working. It wasn't working earlier, so paste. Is it going to work? Yes, it actually did. That's epic. All right, so here we go. So we know that data, which is the angle of interest, data is the angle of interest. It's just the name of the angle. That's all I'm saying. Data is the name of the angle of interest. So in this case, data is equal to 59.1723, blah, blah, blah. Okay, all right. So now, remember, we need to round our angle to the nearest degree, right? So therefore, I'm going to look at the tens place, which is this number here, and I'm going to ask myself, is this number 5 or bigger? And all 209 of you guys should say no. So therefore, the 59 remains the same. So theta is equal to 59 degrees. So I'm going to write this in a different color. So theta is equal to 59 degrees. The measure of theta is equal to 59 degrees. Awesome. All right, so that's it for today. Hopefully this video was helpful. And if you enjoyed the video, remember to drop me your thumbs up and subscribe if you're new to the channel. And remember, we teach a new lesson like this one almost every single day. I'm Mrs. Solis, and I'll see you on the next one.